You can start. Sorry, just noise. Okay. The first part I will introduce how to do the scheduling. And as you can see this figure, this figure is a resource grid, and which can indicate the resource in the air interface. And the basic unit of this resource grid is called the resource block. And as you can see, here are 3 different colors, and different color means the different UE can get the resource from this resource grid. Yeah, and the most important part for the UE is to know when can get the resource, and also where can get the resource. So the scheduler also split into 2 parts: the time domain scheduling and also the frequency domain scheduling. So this is the basic knowledge. Okay.
Here,
yes.
Here, a little bit mistake. Resource grid is the minimum.
You mean the resource element, right?
Yeah.
Oh yeah. Okay.
Okay. You need.
I know. Yeah. I know. Yeah.
The resource grid.
Okay. I know my mistake. Okay. And here here's another example. If the UE and GNOB want to communicate with each other, I mean the UE if want to send some data to the GNOB or get the data from the GNOB must to allocate the resource to UE first and tell UE when and where to get or put the resource. So here has 2 options, and the first option is to send the uplink data to the GNOB. It means the UE get the resource allocation from the GNOB first, and UE know where it can put the data, so that the UE can send the uplink data to the GNOB. And the second option is about the downlink data, and the GNOB will inform the UE on where and when can get the resource. Then UE can get the resource according to the information from the GNOB. So this is another example for the scheduling. Okay, and here I will take the real example for the downlink scheduling. And as you can see, the right hand side it has the message sequence chart, and inside the GNOB, the IOC layer will inform the buffer occupancy to the scheduler. So what is a buffer occupancy? Buffer occupancy is it can indicate the data from the upper layer, and also indicates the amount of the data from the upper layer. So the scheduler can know how many data from the upper layer want to transmit to the UE through a downlink channel. So after scheduler get this information, and the scheduler can allocate the resource according to the buffer occupancy, and then the scheduler will send the when and where can get the resource from the GNOB. And actually, when and where can get the resource is carried by the DCI. Actually, DCI is very important for the scheduler, and you can say the whole range. So DCI will contain the downlink scheduling information. Then UE can know where and when can get the resource from this information from DCI. And then GNOB will send the downlink data to the UE, so the UE can get the data. And another example is for the uplink scheduling. Okay, the uplink scheduling is a little different between the downlink scheduling, because the UE need to inform the GNOB, informs that I want to do the scheduling for the uplink, and then the GNOB know this UE want to do the scheduling request, the uplink scheduling. So the GNOB will send the uplink branch, and uplink branch is also a DCI, which means it can indicate where and when to get the resource, to put the resource for this UE. And then UE is already know where it can put the resource. So UE can send the data, the uplink data, and also the BSR. And what is BSR? BSR means the buffer status reports, and UE can provide information about the amount of uplink data from transmission. It is similar to the BO for the downlink scheduling. Yeah, and then GNOB can read the buffer status report from the UE and also have a uplink scheduling info through the DCI transmit to the UE, and UE can know where and when and where can get the resource and put the resource, and then UE can transmit the uplink data first. This is for the uplink schedule. Okay, and here I show you the common scheduling and dedicated scheduling. Actually, the whole scheduling can split it into two parts. The first part is common scheduling. What is common scheduling? Of the communication between two devices, the most important part is to do the synchronization first. So it's also same as the 5G network. It will have a synchronization between the UE and GNOB. So the first, it will do the downlink synchronization, and it also known as the serial broadcast procedure. And after that, UE have a downlink synchronization with the GNOB. And then UE will do the uplink synchronization with the GNOB, and it is also very famous, which is called the random access procedure. And these two procedures is also called the common channel scheduling. It means we will schedule the resource between these two procedures, within these two procedures, and it can be called the common channel scheduling. And then after the synchronization, and we can start to transmit the data. For example, we can transmit the downlink data. So the scheduler can do the downlink scheduling for the UE. And then also the uplink scheduling. And these two scheduling can be called the dedicated channel scheduling. So the whole scheduling can split into these two parts. Okay. Because today I won't go into detail for the DCI, the format of DCI or the common channel procedure, serial broadcast procedure or random access procedure. So I have have a talk regarding to this part in next 3 weeks. So if you are interested, you can just go to detail. You can click the link to see a slide or see a video. Yeah. And then I will show you the OSC scheduler architecture. Okay. This is the OSC MAC Scheduler architecture, and this is drawn by myself. And after I trace the code, and then I will try to map it one by one, and also do the file mapping between each component. Okay, the first component is called the scheduling trigger, and the scheduling trigger can trigger the common scheduler and dedicated scheduler to do the scheduling. And how to scheduling trigger do that? He can call a function which is called a schedule process slot indication, and I will explain it maybe later. Okay, and the file mapping is this component will map to the slot indication and also the scheduler utilities, these two files. And another component is the uplink and downlink HRRQ handler. This component, it can manage the process for each downlink and uplink HRRQ entity. And what is the HRRQ entity? Which means the entity, the UE need to do the HRRQ. It can be called the HRRQ entity. So it can also do the file mapping in the whole audio high folder, scheduler folder. Okay. And the next component is called the MAC and scheduler API handler. And this handler can handle the message and API between from the MAC, such as the scheduling request indication or uplink buffer status report indication, such as these two API. So whenever the scheduler gets the API or message from the MAC, it will go into this component and try to process it. And it also has a file mapping between this component. Okay, another component is the UE manager. A UE manager means this component can add delete, update the UE configuration, but note that it's only in the scheduler. It means maybe the RC connection, it will have a connection between the UE and maybe the CU, and then the CU will know the UE configuration. Then the CU will send the configuration to the scheduler. So this configuration is only used in the scheduler. So it won't change the real RAM. Yeah. So it also has a file mapping. Okay, and another component is called the common scheduler. And common scheduler can perform the common channel scheduling during the cell broadcast procedure and the next procedure, which I just mentioned, the common channel scheduling. Yeah. And we can just have a file mapping between these two components, between this component. You can see the common reg, round robin, utility. Yeah. Okay. And here is another component which is called the dedicated scheduler. And dedicated scheduler can perform the dedicated channel scheduling I just mentioned before, and which means it can have a uplink data scheduling and a downlink data scheduling. And I also have a file mapping to this file. Yeah. So this is the OSC scheduler architecture. Okay, so I will start to introduce the common scheduler. And I will introduce these two components based on the procedure. Yeah, it may be a little complicated. So the first procedure I want to introduce is the cell broadcast. And I list the module I wrote on this MSC. So the first MAC will send a start indication to the scheduler. And what is start indication? Start indication is used to indicate the scheduler. To indicate the scheduler is to do the scheduling now, right now, yeah. And the period is each slot. So after a slot, the MAC will send a start indication to the MAC scheduler to tell scheduler you should work. Yeah, you should do the scheduling. And okay, and this notification will receive by the MAC scheduler API handler, and then this API handler will have a function which is called a MAC scheduler start indication and send it to the scheduling trigger. And this scheduling trigger will trigger the common scheduler to do the scheduling. Yeah, and this procedure is called the start indication. And then the common scheduler will start to do the cell broadcast resource allocation, including the SSD allocation and also the SID1 allocation. And then the common scheduler will send the downlink scheduling results to the NIC. And this is for the cell broadcast procedure. And for the random access procedure, it's a little complicated. The first part is send. It has a start indication to tell the scheduler you should start it to do the schedule. And then the common scheduler will start it to have a resource allocation regarding to the message one. And then also the send uplink scheduling results to the UE to the MAC.
Sorry.
Yes.
But here you need to get the indication from physical layer. Where do you get the message one?
Oh, here is before we get the message one, because the UE need to send the message one, it also need to get the resource allocation from the scheduler. Yeah. So
here it's only this
before the it's only the DCI, yeah. And then MAC will it will have the message one. The MAC will send the reg indication to the scheduler, and it will also send to the MAC scheduler API handler. And this handler will also call a function which is called the MAC scheduler reg indication. And also it will have a scheduling trigger to trigger the common scheduler to store the UE information. And it will wait for the next start indication and start it to do the schedule. And here is the next start indication. So it will start it to deal with the message 2, also known as RIR. So the MAC will send the start notification. Yeah, it is a start notification. And then it receives the start notification. The COM scheduler will start it to do the message to resource allocation and also the field the next response information. And then it will do the message tree resource allocation together, and then it will send the where it can get the message to and where it can get the message tree to the UE. Okay. And for the message tree, because message tree is a RC connection request, so actually it won't go to the scheduler directly. It will just go to the CU directly because it's a RC connection request. But after the RC connection request, the CU will inform the configuration of this UE to the scheduler. Yeah. So here you can see here is a send UE request to scheduler because the RC there will tell scheduler and there is a UE, the new UE, there's a new member, so you need to add it to the scheduler. So here make send the UE request to scheduler. And the MAC Scheduler API handler also have a function which is called MAC Scheduler add UE configure request and send it to the UE manager. UE manager is I just mentioned, it can add, delete, modify the UE configuration only in scheduler. So here UE manager add a new UE configuration in the scheduler. Yeah. And then the UE manager will send a response to express, yeah, I have added. So this is for the message tree situation. Okay, and then this is also have a start notification, and then the message flow, also known as the contention resolution. And the message flow, it will COM scheduler will also allocate the resource for the message flow and also fill the message flow information, and then send it to the MAC. So this is the whole Linux procedure within the audio high scheduler. Okay, then I will talk about the dedicated scheduler.
Sorry.
Yes.
Can you go to the message one? See. Is it possible to receive multiple message one in the domain?
Let me think. Yes. As I remember, it has a queue to record the message one it received, and after the COM scheduler is triggered, it will handle the whole message one in a queue. Okay. As I remember. Yeah.
Because it's kind of in a render access, they will transmit preamble. So we the physical layer original version of physical layer will only detect send one preamble, one of the detect preamble to the MAC. But Professor T1 already tried to enhance their path, so they are able to transmit multiple preamble to the MAC. Okay. But we are not sure.
Yeah.
Both of them.
Yeah. Maybe I will check it. Okay. The next part is regarding to the dedicated scheduler. And the first part is regarding to the downlink scheduling, and I just mentioned it before. And here, the first part is the ILC where the ILC layer will inform the scheduler how many data I want to transmit. So this API, the send downlink ILC BO information to scheduler will indicate, and there is how many data volume in the ILC, or you can say logical channel. Yeah. And here, the MAC Scheduler API receives the information from the ILC. Then it will store the UE information and wait for the next slot invitation to do the schedule. Yeah. And this can be called the downlink ILC buffer status information. And for the downlink scheduling. So here is also the next slot invitation. And then the scheduling trigger will trigger the dedicated scheduler to start it to schedule the downlink data resource allocation. And this includes the schedule field grant downlink schedule info. You can just say it just can trigger the downlink resource allocation. Yeah. And then dedicated scheduler will fill the downlink message info and also have a PRB allocation, also known as the when and where the UE can get this information. And it can be allocated in this function. And this function will have a parameter which is called the RM policy. And RM policy is highly related with the slicing. Yeah, actually each slicing will be assigned a RM policy, and to that slicing can have a dedicated PRB to do the resource allocation. Yeah, and then the dedicated scheduler will fill the results into the PDCCH, also known as DCI, and also the PDSCH to send the message to the UE. So that UE can know where it can get the data and also can get the data. Yeah.
So sorry.
Yes.
So in your case, the slot indication actually they will transmit every 1 millisecond, right?
Yeah, it depends on the numerology, but yeah, every TTI.
Okay, every TTI, but in here, in your case, is every TTI you schedule only one UE or multiple UE?
Multiple UE.
Multiple UE.
Yeah.
So the slide indication already contains all the information from all the UE.
The information for the UE is in the I mean the information for the each UE maybe it will interface by this API, and this is just to tell scheduler you need to do the scheduling. It just carry the SFN system frame number and the slots and the number of slots. Yeah. Yeah. Oh, okay. Okay. Sorry. Sorry. Okay.
Okay. So I think it's better to show us the major parameter you are using.
Yeah. Okay. I think it's
Directly on your video, so we can know. For example, now if you want to do the scheduling, you need to know the buffer status for all the UE. It should be a UE list.
Yeah.
So based on the UE list, you do the schedule.
Yeah.
But what kind of in your previous video, I go back to the functional block diagram, the metric for dedicated scheduling. Yeah, for this part, they don't need to use SCHRR.
Yeah.
Right?
Yeah. Actually, this file has only two functions and only support for the range. So actually, the file architecture in the OTU high is a little messy.
Okay.
Yeah.
So do they use SCHRR is a round robin, right?
Yeah, but the function in there.
To your description, round robin is only used for command channel.
Oh.
Next one.
Yeah. It's only for.
It's only.
Yeah.
The command scheduler they use round robin, and the dedicated channel they don't mention.
Yeah.
But for command channel, why do you need to use round robin?
Actually, I think the function in this file is a little weird. The function in this file is to do the retransmission for the message tree and get the time domain scheduling.
Oh, okay.
Only this function, so it's weird.
To deal with retransmission.
Only for message tree.
Only for message tree. So I think you highlight it.
Okay.
But in your dedicated channel scheduling, I think you also need to use round robin.
Yeah. So they write the round robin in this file. Yeah. So it's a little messy, the file structure. Okay, oh, this folder. Yeah, okay, I will move on. Okay, okay, I think I have finished the Downlink scheduling, and next I will start to talk about the uplink scheduling during the scheduler. And okay, the UE will send the scheduling request or the DSR. Actually, these two requests is different, but here I only show you the one of them because actually the function is different, but the procedure is almost the same. Yeah, and the UE will send the how many data the UE want to transmit, and then the MAC will send this information to the MAC scheduler data handler, and then then this handler will store the UE info, which is indicate this UE want to transmit how many data. Yeah, and then it will wait for next notification and to do the schedule. And this procedure is also called the uplink buffer status report indication. Okay, and after it got the scheduler got the buffer status report for the UE, and also has a start indication, and the dedicated scheduler will be triggered and started to do the scheduling. And then the dedicated scheduler will call the function which is called the scheduler process scheduling request. Yeah, just like this function name. And also it will allocate the time domain resource and frequency domain resource according to the RM policy. Maybe only for the frequency domain resource. Yeah, and this procedure is called the uplink data resource allocation. And then after the resource allocation, it needs to fill the allocation results into the DCI, and also fill the data, the data want to transmit to the UE into the BUSCH. And then the UE can follow this DCI to know where it can get the data, when and where it can get the data, and yeah, and the UE can get the data finally. Okay, and this is my presentation, and it's a Q&A time.
So for how does the scheduling result send to physical layer?
How to?
I guess. So finally, you send the uplink scheduling to MAC, then MAC pass it to physical layer.
Yeah, yeah.
Okay. So where does the UE, does the base station take to decide the modulation channel coding in here?
You mean the MCS, right?
Yeah, MCS.
Let me see.
Yes. You also need.
I think it will integrate in the DCI here, this function.
The DCI.
But yeah, it will be carried by the DCI.
But you need to calculate the resource allocation first. Okay? You need to know the modulation and the coding scheme that you can know the
TBS size.
Yeah.
Oh, actually, there's a function called the SCH calculate TBS size, but I don't see.
Try to figure out.
Okay.
Because finally, and then you, after knowing this, you need to tell us if this is only for single base station. If we want to provide network slicing, what are the functions you need to support network slicing? Because now, if you consider network slicing, you need to partition the physical resource into two parts. Then the two slices, actually, they are able to schedule in parallel. You may be able to use two threads to duplicate one process. They can do independently.
Yeah, okay.
Yeah. So if you are able to do this, this would be your contribution to extend single bit to provide slicing.
Okay.
But you also need to think about in release E, as I remember, release E Redis is already demonstrate they are able to support network slicing.
Yeah. Like I
want to
mentioned.
know how they do it.
as I mentioned in this function, it will allocate the frequency domain resource, which is the PRB, and according to the RM policy. And actually, the different RM policy can associate it with the different slicing. So, the dedicated scheduler finally will allocate the PRB according to the RM policy.
Sorry, means that when you have two schedulers,
yeah.
If you want to do slicing, actually you need to have two schedulers.
Yeah.
Each scheduler for one slice.
Yeah.
But if now you want to have a joint scheduling from the two slices, means that slice one, for example, you want to schedule a UE. This UE need to have information, data from slice one and slice two.
Yeah.
So see the implementation. They just use scheduler one to do this.
Yeah.
But think about when you have two slices, two schedulers, how can you do it?
Okay.
Basically, you will have two resources. They will schedule independently.
Yeah.
Then you need to merge them into a single CCI. So I guess the concept they propose maybe not directly, maybe not real slicing. Yes. So think about it. Tell me how do they implement it? Detail. How do they?
Okay. Maybe I can show this function in detail and also explain what is RM policy.
Yeah.
Okay.
I get it. So, sorry, a little question.
Yeah.
How to test your OSC scheduler?
OSC scheduler.
So because you list a lot of functions, right?
Yeah.
I just want to know how to get the analysis result.
Analysis results.
Yes. How to test it. So we show the environment.
You mean for the radices now or?
Yeah, you can tell us how radius is. In
Okay.
radius, in release E, they have a demonstration. I guess they just use OCU stuff like the ODU load stuff.
Yeah, 5 stuff. Yeah.
Yeah, 5 stuff to test it. So maybe you can try to check the demo they use. Maybe you can check with NT directly. You ask him, we want to duplicate the result of release E for the network slicing. So please tell us how we can test this idea.
Okay.
So I think Professor Adi point out very important issue. How do you verify? Because you just mentioned how that you have one UE and multiple UE, right?
Yeah.
So how to challenge your schedule very well.
Okay. I will try to figure it out. Thank you. So any question? Oh, you mean this?
If we want to
Yeah. Actually, they go through the 4 UE in the function, such as maybe this, yeah, and it have a for loop to from the UE, for example, UE 0 and to the UE maybe 100, yeah, it will go through the whole UE list, yeah, in some random. So yeah, so they don't write the for loop in the outside. They just in some function, yeah.
Let me give a short comment. Actually, the slide indication is triggered by physical layer.
Slide? Oh, sorry.
Not slide indication.
Yeah.
Triggered by
By, yeah.
physical layer will trigger if every one slot.
Yeah.
So the slot indication will be carried through the control interface. No, sorry. Will be triggered by physical layer ODU load.
Yeah,
ODU load will use FAPI.
Yeah, right.
Trigger the slot indication.
Yeah.
So it will physical layer will trigger slot indication in every 1 millisecond.
Yeah.
So actually, everything we are talking about here should be finished.
Yeah.
Should be finished within 0.5 millisecond.
0.5.
Yeah, because 1 millisecond is after 1 millisecond you will receive the next one.
Yeah.
Before that, you need to finish. The physical layer also need to have time to process.
Yeah.
So this is one challenge.
Yeah.
Then when we move to 6th generation, the slot base. Now we are talking about slot base scheduling. But in 5G, they already support so-called mini slots.
Yeah, I know.
Yeah, mini slots scheduling. So the indication will be the indication interval.
Yeah.
Even somebody is talking about the symbol label.
Yeah.
Scheduling.
Yeah.
So there are lots of challenges.
Yeah.
Because yesterday, Compare, they just have talking about this part, and they said that in your ODU, if your processing time is too high, it's never achieved the requirement.
Yeah.
So this part, I think, complexity is the key. How can we simplify? How can we use? So if you are checking this part, actually try to estimate the time required for each module. Then when you go through the OSC code, you can know which part dominates the timing. Then we can think about how can we enhance this part. Yeah, that would be very critical issue. So this is one key. Another key is the power consumption also heavily depend on this part.
Power consumption.
Power consumption.
Oh.
Power consumption. Bimo just mentioned about the energy consumption, energy issue. Energy issue would be quite important. So the computational complexity here should be also a key.
Yeah. Yes. Okay. Yes. You consider against the power consumption.
Common channel in Downlink, the first one.
It will indicated by let me see. The MID, I think. In the cell pocket, it has the initial bandwidth part in the assigned in the MID. Yeah. What?
If you want to apply those parts, it's options.
It is what?
Options.
Do you mean the UE can want to?
I think for Yuhan's question, in the base station you can provide different options.
Yeah.
For bandwidth part.
Yeah.
So for each UE, the bandwidth part can be configurable.
Yeah.
So this part, this configuration per UE count, here is for common channel. So here, the bandwidth part transmit common channel is for all the UE before making connection with the base station. They will use initial bandwidth part. And later on, if they want to change the bandwidth path, the only way is through the RRC connection, control signal. So the basic concept is quite simple. You have common channel. Common channel scheduling is for all the UE who did not get a resource. So you follow the step, get from common channel, downlink broadcast to get all the information you need to perform random access, to read, to get the resource from paging. So after that, you can keep in idle mode. In idle mode, if you stay in idle mode, you just follow common channel schedule. If you want to move to connecting mode, you need to perform random access first. After the random access, you can get a dedicated channel. With the dedicated channel, you can adjust. The base station is able to adjust UE specific parameter through RRC. So the configuration actually is not in MAC, it's in RRC, it's in CU. So the core part for the CU, one is the interface with the other component. Another part actually is in RRC. In 5G, the QoS requirement is also important. So SDAP regarding to the QoS control, because you need to use SDAP to configure here. I'm not sure whether they consider the QoS. No, not yet. Okay, because for this part, you need to the different UE will have different QoS flow. So they will be indicated by QFI. Then you need to use the QFI to allocate bandwidth. So this configuration should be configured to the MAC. This configuration actually they need to be informed. They need to be considered in the UE schedule. Now here, the initial version, they don't consider all the detail. All the functions are able to include it. So that's why if we want to do, if your research want to be built up on top of the open source, first of all, you need to know the current status. What did they have? Studying the code is quite complicated, quite difficult. So you need to go through a spec. But you are not reading the spec from the first page to the end. We have a seminar yesterday. Somebody mentioned the RF spec from the first generation is only a few pages. To the fifth generation is 15,000 pages. So all the other spec is almost the same. The spec can at least RC IC spec is at least 300 pages. So it's not possible for you to understand all the detail for all the message. What you need to do is to follow the procedure. Start from the common channel, start from the random access, then dedicated channel. Then you can think about what are the important, what are the necessary, and you can based on the spec. If you are able to list the message, the mandatory message, you can use this one to compare it with your source code. You can check whether Redis is implement a function or not. So you can from the implementation from Redis is actually you can learn something from their engineer. What are the important? How to set the priority? I think this is quite important. RC have 300, so it's not possible for you to primarily study all the 300 page detail. So how do you choose maybe 1 page, maybe 10 pages from the 300? This is the key. So you can learn from the open source, learn from the source code. Why I ask you to compare the source code with the spec? Because from the source code, you know what are the functions they implement first. So you can learn how do they set their working priority. You know, all the companies like us, you get a new spec, you need to determine, you need to decide which function to be implemented first. So this is a good opportunity. So that's why I ask you, don't tell me you want to study a spec. You need to tell me which part of the spec you want to study and the why. The most important is why. This page is why. This page is why. If you don't know forecast procedure, you don't need to go into detail for the rest of them, because you never understand what are the information to be broadcast from to node B. And when you're doing this, you also can think about it. Which of the parameter should be adjustable, should be configurable. Okay, for example, when you are doing the scheduling, you need to know how many PRB do you have if you want to consider slicing. So in the implementation, initially they will give a fixed value. They will write the table in the console, because if you want to write the source code for ODU, some configuration actually come from OCU. But without OCU, how can you do your part? So they will assume they will give you a specific numerology, give you certain assumption. They use this assumption to set the parameter and use the fixed parameter in the source code. But you know, after all the tests, your source code is only valid for this specific numerology. In the future, this numerology should be adjustable, for example, by OAM, by SF, by RIC, or by RC, by OCU. So when these parameters are changed, can we ensure the source code design in the ODU still be valid? That's the challenge. Okay, so for everybody, try to start your job by studying the code. Every master student try to study the detail. For PhD student, you need to know the overall. You need to try to identify the priority and divide all the master student to detail for one part. When our team know more detail for each part, then we are able to determine your thesis topic. Don't mix the order. Okay. Any other question? I think